Today's discussion is on section 9.4, rotations. Our goal is to rotate figures about a fixed point. So a couple definitions to start. A rotation is a transformation in which a figure is turned about a fixed point. This fixed point is called the center of rotation. And when we rotate a figure, we rotate it a certain amount. This amount is the angle of rotation, and it is counterclockwise for positive. And thus, if you are going clockwise, you are doing a negative degree rotation. We are going to do this activity in class in which we are going to rotate an image about a point. So we are going to rotate this about 100 degrees. Coordinate rules for rotations. Again, just like the reflections, there were rules for how a point was reflected. There were also rules for how a point is rotated. Our first one, if AB is rotated 90 degrees counterclockwise, so a positive 90 degrees, the image point becomes negative BA. If a point is rotated 180 degrees, AB becomes negative A, negative B. And finally, 270 degrees would be B, negative A. Note that 270 is the same as negative 90 degrees. 180 degrees is the same as negative 180. And lastly, 90 degrees is the same as 270 degrees in the negative direction. Find the image of GD with G being the point negative 3, 4, and D being the point negative 2, negative 5 after each rotation below. So we're going to rotate it 90 degrees. Our pattern says that this will be negative BA. So G is the point negative 3, 4. We rewrite the pattern as negative BA, so we have negative 4, negative 3 is G prime. And we will do the same thing with the coordinate of D. So D is the point negative 2, negative 5. And this becomes the point 5, negative 2, and again, that is D prime. Repeat this for a rotation of 270 degrees. So 270 degrees, the pattern is B, negative A. So if we have G again was negative 3, 4, and D was the point negative 2, negative 5, we rotate them and get the points 4, 3, and 5, 2. Just like with reflection matrices, there are rotation matrices. So we have the 90 degree rotation, the 180 degree rotation, the 270, and the 360. The 360 you don't have to really worry about because you get the pre-image is the same as the image. Same matrix. You're rotating it right back to start. Really nothing going on here. So we have here, the problem says, find the image of the trapezoid represented in the pre-image matrix below after a rotation of 270 degrees. The transformation matrix always goes first. So our matrix for 270 degrees is as such. And again, remember, we are multiplying row by column. And if we look at this, again with the zeros and ones, and the beauty of the transformation matrices is that when you're multiplying by zeros, you're basically eliminating a row. So this becomes 0 times the first element, so we have 0 times 5 plus 1 times negative 2. So this becomes just 1 times the second row. So we get -2, -4, -4, -2. And when we look at the other one, it becomes -1 times the first element plus 0 times the second. So the second row is essentially crossed off, and this becomes -1 times the first row. So we get -5, -4, +1, +2. This is our image matrix after a rotation of 270 degrees. Lastly, a rotation is an isometry. That means it is a congruent transformation. So when we have here where it says find the value of R and S, these problems can be tricky, but if we follow the side from the rotation and trace it, we now have this green segment here is equal to that green segment there. So we get that 2S equals 12 and S equals 6. And now as far as finding the other side, we're trying to find 3R. Well, if we look at 3R actually intersects where our green line is, our line of rotation. So that means it's going to be here. So we're going to have 3R is equal to 2S plus 3. Two variables, but we already know the value of S, so we are going to plug that in. So we have 3R equals 2 times 6 plus 3. We get that 3R equals 15. Divide and get that R equals 5. We have no units in this case, and we are done. Nothing to plug in, just solve for the variable.